All right, how do we work with this? So we're going to do something quickly. We're going to rewrite this, and then you'll see that what we're going to do is separate the coefficients from the powers and deal with them separately. So I could think of this as just 8.5, right? I'm just multiplying all these things together. So 8.5 times 10 to the second power times 1.7 times 10 to the sixth power. And remember though, when we multiply a bunch of numbers because of the commutative property, we can put in any order we want, right? So this is the same thing as saying 8.5 times 1.7. Notice I'm putting the coefficients next to each other times 10.2 times 10.6, right? And now I'm putting the powers together. And so I could just actually deal with these separately. So I can just do 8.5 times 1.7, and that is 14.45. So that's just 14.45. And then times, so it's coming back, 10 to the second. I have 10 times 10. 10 to the sixth, 10 times 10 times 10 times 10 times 10, right? 6 of them. So I have 2 of them, another 6, that's 8. So that's times 10 to the 8th, right? Now, last step. Remember, we need this in scientific notation. So we can't have 14.45. We need that to be 1.445, right? And so now the question is, what are we doing to the decimal place, right? So how do I move that 1 back over? So it's actually going to be 10 to the 9th, right? We're going to have to multiply that by 10 to the 9th to get it back to its original amount. Okay, so 1.5 times 10 to the negative 3 squared. So again, this exponent is being applied to everything inside. So this is the same as saying 1.5 times 10 to the negative 3 times 1.5 times 10 to the negative 3. And as we just saw, we can think of, or we can deal with the coefficients together and then deal with the exponents together. So I can rewrite this as 1.5 times 1.5, or 1.5 squared, and then times 10 to the negative 3 times, I'll write it like that, times 10 to the negative 3. Right, and so 1.5 times 1.5 is 2.25, and then times 10 to the negative 6th power. And notice 2.25 is already between 1 and 10, so we don't have to do anything else with that. All right, we're going to do one more, right? So I'm just going to write this one in. 1.2 times 10 to the 4th over 1.6 times 10 to the negative 3rd. Okay, and the reason we're doing this is because we got to review really quickly what that negative exponent means. Remember, the negative exponent tells us to take the inverse. So that means if it's in the numerator, it's coming down to the denominator. But in this case, it's in the denominator. So this is actually going to go up. We want to write this as a positive exponent. So that's actually going to come up and be positive 10 to the positive 3rd, right? So we can rewrite this as 1.2 times 10 to the 4th times 10 to the 3rd over 1.6. And so now, just like we did in the last example, we can work with the coefficients separately. So we just have this, right? And then we can have the powers, we'll think of those together too. So 1.2 divided by 1.6 is 0.75, so we have 0.75. And then 10 to the 4th times 10 to the 3rd, so I have 4 of them, another 3, that's 7, so I have 10 to the 7th. Okay, so right now you're almost done. The problem again is that 0.75 is not between 1 and 10. So I'm going to need to move that 1 over, right? So I have 7.5. But by doing so, we're going to have to make this 10 to the 6, right? Because to move it back to where it was, we'd be going 1 to the left to make it 0.65. So we'd be dividing that by 10. And so that's why we're going from 7 to 6.